A and B. Any other problems in chapter 6? 32. Oh yeah, 32. That's on 101.
All right. I'm going to make this list too.
But I don't have any other questions out of chapter 6?
22 and 32.
Oh, yes. Yeah, 27.
And what else?
27.
27. Okay. All right. And then chapter, what else?
Chapter
3? 2 and 3.
I had point 1 at first.
Chapter 3 questions, guys. Come on, let's go. Quick.
I gotta look at it. Yes, the question.
Okay. Going once, going twice. Anything on chapter 3? Do you have questions on?
33.
33.
33.
And when did you do 33?
That's on chapter 2. It's chapter 2. Did we do this
Oh.
last night?
Did you do what last night?
Oh, wait, that's the next one. Sorry. Oh, okay. I was like.
So what now?
That's
For tonight? Is that what you mean? Okay. So, oh, you can't see this. Sorry. There you go. Okay.
Chapter 2, 26.
Chapter 2, number 26. Okay. Anything else? All right, let's get started. Where do you want to start? Should we start in chapter 6? Work our way forwards?
22.
Chapter 6, 22. All right, let's look at it. Oh, I love this one. Awesome. I'm so excited. Fabuloso. Okay, here we go.
I even drew a picture.
High five for that. All right. Guess what? There's another ranking test like this that I have up here for us to do today. So this will be great. So pay attention. All right, here we go. So the situation is that you've got a box. No, because I want to make sure it actually sticks, right? Yeah. All right, so you've got a box. You've got 2 arrows, 2 forces pulling on it. One's going to the right and one's going to the left. And they're of different magnitudes. And the box is of a different mass. I'm just going to write down the combinations here real quick if that's okay. So I've got A is 5 newtons this way, 10 newtons this way, and it's a 5 kilogram box. B is 10 newtons this way, 15 newtons this way, 10 in the middle. Oh, you guys, this is great. This is like such a good problem. I'm so glad you asked about it. D is 5. And then there are 2 different things that they want us to do, right? Double your money. Here we go. All right. Here we go. So A asks you to rank the net force. You say, what? What's net force? We haven't used that term, but what is net force? What have we been talking about it as? The sigma-y thing, right? Or the total force. So you can call it whatever you want. Basically, you're going to add up all of the forces, and they want to know which one has the biggest all of the forces. Forces have both magnitude and direction, and that's important, right? So let's do it. Let's just find the net force. If I've got 10 newtons pulling this way on A and 5 newtons pulling that way, what is the net force here?
5. Isn't it 5?
I've got 10 going this way, 5 going this way, 5 going this way, right? 5 going to the right. So if we call this direction the positive direction, this direction the negative direction, you with me there? Okay, positive and negative. Did I do that the right way for you guys? Nope. Then it's going to be positive 5 newtons. Everybody okay with that? Okay, figure out the other ones real quick. Go.
Oh, and sometimes, like, for example, if you were to do 10 minus 15, you'd get negative 5, right? But how would you know, like, so you always subtract from right to left?
You always make the one that's going positive, the one that's going positive, and the one that's going negative, negative.
Yeah. Oh, yeah.
Did I answer your question, or was I like being
Yeah,
obtuse?
I just feel like you add, because minus equal, they always subtract.
See, that's
Oh, yeah. Always add. Yep, because sigma means sum, right? It doesn't mean difference, it means sum.
all of the other ones.
All right, so do we get our sum of the forces on the other ones on B? What is it on B?
5.
+5? What about on C? How about D? How are we doing? Can you rank those?
10 is greater than, so D is greater than C equals B equals A.
Yeah.
That's, wait. Hold up.
Was that not what it said?
No.
It said D
Wah, wah.
greater
Is
than
less
A,
than.
or less than A, which is equal to B, which is equal to C. I thought that was just.
Maybe should I just put a less than instead of a greater than?
Yeah, oh, was it a
Yeah,
mistake?
probably typo. Sorry, Carmeling messed up. Wah, wah. Sometimes when she goes fast, she doesn't, yeah. Mistakes happen, right? That's why we use erasers most of the time.
So you don't add them, like the bottom, like 5 and 15?
You add them, but it's going to be 15 newtons plus -5 newtons. Is that okay? Thanks for asking. That's a good question. Does that make sense to everybody? Yeah? So you do add them because it is sum, but you have to pay attention to the negatives and positives. How's it going? We okay? Okay. Now, this is the fun part. Part B. Yeah! Part B says rank the accelerations. Now, we were like on the precipice. Do you know what I mean when I say that? Like, here, let me show you what I'm talking about. Oh, did I tell you guys? Do you remember a couple weeks ago I was telling you that I had that dog and I wasn't a big fan of it, but I couldn't find my what? My frog? I found him!
Okay, that's what people are talking about.
Right? I know! I love him. Anyway, I found him. He was in a box when I was here over Thanksgiving break. I was like, I found him. So excited. I kind of made a little loud noise, but nobody was here to hear me, so it was okay. So we were standing on the precipice. We were almost there, but we didn't write down. We didn't write down the equation. Now, you could have looked in the book, right? True? Yeah? Maybe you didn't. I don't know. Let's find out. We found out that the acceleration of a cart depends on 2 things. Yes? Yeah? I'm going to go back. So this is teaching happening while physics homework is happening. Are you with me here? Teaching is happening. So you might want to write this down in your notes. Here it comes. Because that silly bell, because we had to get up early yesterday. Man, I would totally rather hung out with you than the teachers I had to hang out with. Jeez. All right. We're going to relive our graph life here. Who is in charge of force yesterday, or not yet, like 2 days ago when we did the lab? That's the M2 people, right? Raise your hand if you're an M2 person. M2 represent. Was it just one group? 2 groups? Maybe a couple? Okay. Tell me about your graph. What did it look like? It went
the opposite way.
this way or this way?
The opposite way your graph went.
Well, I don't remember which way my graph went. So describe it to me. Use some good mathematical terms.
Okay.
Yes, please.
The larger the mass, shorter the time.
Okay, but I want you to get to here. So the larger the force, the
Faster the acceleration.
so wait, what?
Faster the acceleration.
So the bigger the acceleration, the higher the acceleration? Yeah? So did it go up like this?
Can I check my math?
I'm looking at Haley. Do you remember?
I think
It did. It went up like this, right? Yeah, it should have. Darn well better. I remember because yours had that one little outlier, right? But it was basically, so for those of you that didn't do M1, you can write this down now. We're going to write it down. So because even though you didn't do it, you're responsible for it. Welcome to physics. Yay. From the lab. Okay. If you weren't in charge of it, you're going to write it down now. As the force increased, and so if we're going to draw ourselves a picture, we'll come back to problem whatever number that was in a minute. But here's my little cart. Here's the pulley. There's was that M2? Is that what we called it? There's the table. Okay. as M2 increased, we decided that the force increased. Are you with me there? Okay, so we're going to write that down. M2 went up. That meant that the force went up. And as the force went up, based on this fabulous graph that they made, yeah, the acceleration also went up. And ladies and gentlemen, it was like a line. It was pretty lovely. Now, Magda's going to be excited because right now, this is the time where we put our math skills and our physics together. We're applying all of those things that we've learned in math since like 7th grade math, ladies and gentlemen. You know what the equation of a line is, don't you? Yeah, she says with so much enthusiasm, right? Y equals mx plus b, yes? Now, it should have, and I don't remember if you guys did for sure, but that line should have gone through the origin. And if it goes through the origin, what's b?
Yeah. The origin.
It should be 0.
0.
She's saying like,
Say adios, goodbye. Yeah? Everybody okay here? Are you with me here? Yeah. All right, so we know that y, which is a, is equal to some weird slope thing times f. Are you with me there? Okay, that's the slope. We don't really know what the slope is. Don't know what the slope is. We'll figure it out in a minute. The acceleration is dependent on force, yes? As force goes up, acceleration goes up. Everybody happy? Okay, I'm going to pause there for a minute. And then I'm going to go to my other graph. My other friends, when they graphed, they had acceleration over here. And what did you have down here? Number of bars, but that was a measure of, not weight, the mass. Yeah. And you did it was a little bit funny because you did it based on bars, right? Not based on kilograms, which is like, happy fun stuff. But it's all good. But it was something like this. Now tell me about your graph.
not the exact opposite.
Was it a straight line?
No.
Hope not. Yeah, it was. Okay, so now I need my math brains on. Math brains on. That's not perfect. Let me, because that looks like it's going to run into the axis. Let's try that again. All right, my friends. My fancy pants math people, it's not a line, is it? What is that? Do you know?
Isn't it like based off of 1 thing?
It doesn't start with a P.
Does it start with a Z?
No. I was like, what starts with a Z? I don't even know. No, starts with an H. It's a hyperbola, which you may or may not be familiar with. And if you're not, it's okay. Does anybody know what a hyperbola does? Like how a hyperbola works? Short. Yeah, short. Do you know what the equation for a hyperbola is? Yeah, it is. And it might not be one. It's some constant, right? So I'm just gonna put a C. Yeah, exactly. So y equals some constant over x. Are you with me there? Yeah, worth thinking. You guys, this is like deep. This is big deal stuff, friends, because we are gonna get here. It's gonna be awesome. I'm super excited. What is y in this case? That constant we don't really know. What is x? M. Yeah, are you with me? So now, this is so exciting. I can't even tell you how excited I am right now. Oh my gosh! We have two things that both tell us something about A. A equals something times F, and A equals something over M. I'm going to take those two things, I'm going to smash them together because there are only two things that matter, right? F and M. Check it out. This is the time to get your glitter pens out. This is the time to get the sequins out and the blinking lights. Here it comes, ladies and gentlemen. We're going to write it in, I don't even know what color. I can't even decide. Green highlighter. A. I know, right? Whoa! A is equal to, there's something in the numerator. It's an F.
Is it over mass?
There's something in the denominator.
Yeah, because we just had that formula last night.
Right? But look at this. See, you want to know something sneaky? Isaac Newton found this out. Isaac Newton gets credit for it. But look what you did. You just did it yourself. You just did it yourself. It didn't even take you very long. I mean, come on, right? There it is. That's it. The size that you wrote this, that I wrote this, should imply something to you. It's important. It's a big deal.
Can you write on our equation?
Yeah! Good call. What color should we write it in?
You have red?
I do.
You write it in Christmas colors.
A equals F. I'm going to be a little bit more something here. And I'm actually going to like mix our notation, but I'm going to write that as F net over M. I'm going to write it down again too if I can. Here's the thing. And I'm not trying to say that we're not smart. We figured this out without any help from him. Don't you think that there were plenty of women and men prior to Isaac Newton that also figured this out?
Yeah, but they never, but like, we only know that Isaac Newton was the one who did it because he at least, like, he later on said that he discovered it.
Because he's like, look at me. Yeah, no. No love to Mr. Newton. I mean, you can write it down that way. And honestly, if you look in most textbooks, they would write this as Newton's second law. Here it is. It's Newton's second law. They often also, because they know that children are scared of denominators, have I told you that some year for Halloween, I'm just going to dress up as a denominator? I haven't figured out how. That's why I haven't done it. But because children are afraid of them, right? Oh no, not a denominator. I hate fractions. Often they'll write this, they'll multiply by M, and they'll just say F equals MA.
Wow.
So you may have seen that before, but this is the right way to write it, and I'll tell you the reason. It's a cause and effect thing. Effect, not affect, effect, right?
Effect.
Wait,
The force and the mass are the cause. You apply a force to a mass, and the effect is what?
A.
That you accelerate.
So effect with A.
Well, it depends on which way you're saying it.
So the force is a.
The force affects the motion,
That's what I'm
A,
saying, yeah.
but the effect of the force acting on a mass is acceleration.
Yeah, okay.
Yeah, it's like, bam.
If that works for you. Whatever makes you happy. Okay, that was just a big deal that just happened there. Are you guys excited about that?
Yeah.
So glad you're here today. All right, so let's go back up here. Now that we know all of that business. Okay, so back to 22, right? Okay, let's remind ourselves of what was going on. This is going to be easy now, guys. Okay, so the question said, what is the acceleration? Rank the accelerations. I know because we just talked about it, that the acceleration is equal to the force divided by the mass, yeah? And it's the net force or the total force, the sum of the forces. Okay. Do I know the net force in each case? Yeah, because I already found it. That's these numbers here. Right? And then what?
Then you plug in the mass for the box into that.
Ding, 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 ding.
I'm a genius.
You are a genius, just like Isaac Newton, maybe even smarter. All right, so 5 divided by 5 kilograms. Do you see how I caught myself there? Yeah. Because now I'm really afraid because you're like, are you trying to call me something bad when I said that you were as smart as Newton before, remember? Yeah. No, that's why I wanted to clarify. All right. So now you all can figure out the accelerations. Go ahead and do that. Rank them in order. Maybe I made a typo again. We'll find out. I don't know. I so enjoy you guys.
So, we hadn't talked about this yet when you assigned it. I know, but So I was thinking, and the object's not moving, therefore it's 0.
Okay,
And so
what of it?
I just don't.
But I'm not grading this for correctness today, right? So yeah, a learning opportunity has arisen. Yay! All right, do we do it?
So it'd be A equals D is greater than B.
A equals what?
Oh, shoot.
That's what you meant. I think that's what you meant, right? So just to clarify, to get us all on the same page here, we've got, this is 1, what are the units on this thing? B was what? Yeah, is that okay?
Yeah.
Look how smart you guys are. Sweet. All right. Did we get number 22 done?
Yeah.
Good for us. All right. That was fun. We just learned a lot of stuff there too. Like that was fabulous learning that just happened. Good. On a Friday even. That just made the Friday even better, right? All right, 32. Here we go. Whoa, A equals F over M. That's amazing. All right, 32. That was another one. Terry says that if if an object has no acceleration, then there are no forces exerted on it. Sherry doesn't agree, but can't provide an explanation. They both look to you and you say,
Sherry, you still you can't even explain your own.
who's right?
I don't know why Terry is right. I thought Sherry
I
was.
thought Sherry was right.
Yeah, because you can get a constant speed,
Where's this number one?
right? Like, that's how I thought about it. And there's something,
And no force
this
or
is not
exerted.
accelerating.
Like,
And doesn't
like-
gravity act on everything?
Yeah.
That's
Yeah,
right,
yeah,
that's
yeah,
what my
so
Forces
explanation
are always
was.
acting. They're always exerted on the object, but the object does not have to move.
Yeah, no, Sherry's right.
But I guess
That's what I'm saying.
Come on, Sherry.
I think-
Come on, Terry. Who's wrong? What did I write?
Terry.
Uh-oh. Sorry. I don't know. I mean, it's just one letter, right? 2 letters.
No, 'cause I literally.
Don't ever trust Miss Carveling. That's the moral of the story.
Right.
Yeah.
I don't understand.
Okay, so,
No, it's gravity. How? I don't know.
okay. Here's my frog. What forces are acting on my frog? He's right there. So we're going to be really good kids, though. We're going to say that's the force of the... And what's this one?
Isn't that the normal force?
It is.
Just because I want to remember that.
I love it. All right. If an object has no acceleration, hey, this object has no acceleration, it's not going anywhere. Right?
Maybe it's moving at constant speed.
Or it could be moving at a constant speed.
But it still has stuff acting on it.
Either way, I mean, this one has no acceleration. Would you agree? He's sitting right there. Not speeding up, slowing down, or changing direction. Are there forces acting on him?
Yes.
Is Terry wrong?
Yes. I don't know which one is who. That's not.
Terry's the first one. I'll read it again.
Yeah.
I'll read it again. Here it comes. Terry says that if an object has no acceleration, then no forces are exerted on it. What was that?
Yes, Terry is wrong.
Terry is wrong, yes.
Yeah.
What did my thing say? What did my answer say?
Terry's correct.
What? I'm crazy. Cross that out. I'm sorry. Carveling sometimes makes mistakes. I do this when I don't know. No promises. No, yeah, I don't know. No excuses.
I sat in my room like 15 minutes trying to figure it out.
Did I not tell you? Now, to my credit, did I not tell you that when I give you answers, there's no guarantee? And there's even more to that. If you get stuck, and this goes forever, ladies and gentlemen, if you get stuck and you're sitting there and you're like, come on, you can send me a message, send me an email, be like, hey, Carveling, what are you talking about? And then maybe also say, I'm working on number blah blah blah, and I think I got the da-da-da. I totally respond to you. 35 seconds later, you'd be a happy kid. You would have had 14 and a half minutes to shop for Victoria's Secret or watch whatever on Netflix or whatever you wanted. Are you with me there?
Right.
Okay. So Terry
So this was right.
is
I
wrong.
do my homework at like midnight. So
I have a baby that wakes up all the time, all night. Like literally, somebody emailed me at like 12:45 one day, and I was like, oh. So I mean, like, why is Carlin emailing me at 3 in the morning? Because my kid doesn't sleep. That's why. Okay, can we cross it out? Someday she will. I'm convinced.
okay.
27.
She'll appreciate it.
Or yeah, and then she won't ever wake up. Unless she'll be like, I don't want to get up. I'm a teenager. Blah blah blah. 27. Is that right? Calculate the acceleration. Oh, but now we have an equation, so life is good, right? Of a 300,000 kilogram jumbo jet. That's a big jumbo jet. When the thrust of each of its 4 engines is 30,000.
4 engines.
Yeah, so I didn't multiply by 4, did I? Wah wah. So another 15 minutes wasted.
Oh no, I figured it
Oh,
out.
okay.
I got 0.1. I'm like, no, that's I totally.
Okay.
Gotcha. So did I do that one right, or did I do that one wrong?
No, you did it right. I was just
I
like,
get it.
I was like, I said 0.4.
Multiply by 4?
4.
So we good?
Yeah.
All right, sweet. Can I keep moving on, or no?
So if we get another question like this, do we have to multiply the number by the force, or can we just get our answer and then multiply by 4?
So where are you asking when you need to multiply by 4? I don't care. I mean, if you were like writing it all out, right, you could either say the acceleration is equal to the force force divided by mass, and then times 4 engines, or you could say the force times 4 engines divided by m. They do the same thing. It's the commutative property of multiplication, or what? I don't remember if that's the right property, but do you remember learning properties of those things in middle school or something? I don't know. They're important to somebody, not so much to me. But anyway, okay. Good with all those? Woo! I know, we learn a lot though. And then number 26. Are you guys mad at me about number 26? Oh, this is chapter 2. Chapter 2.
Oh, were you here the day we went over that? Dylan?
No, it wasn't.
Oh, did we go over that one when you were here?
Probably.
Okay, I thought we went over that one.
We did go over that one. We'll do it real quick one more time just so that Dylan is happy. 2 forces have one having a magnitude of 20, another having a magnitude of 12. So you have 20 going this way and 12 going this way. You see there?
That's it. So then you just
8.
add them.
And then you could also have 20 going this way and 12 going this way.
Oh, see. Okay.
Does that make sense? Or any combination thereof in between. All right.
But you can have them like one going up.
You could, then you do some Pythagorean Theorem.
Did you have to do that?
No. We talked about it, but we didn't have to do it.
Okay.
It wasn't required. I talked it through because I wanted to show you that it could be anything in between whatever was
Okay.
8 and 32. All right.
What do you think?
How are we doing, team?
What do you think?
We okay? We don't have a lot of time left, do we? We just have a few
No, we
minutes.
For one.
Just enough time for like a little bit more stuff. 5 more minutes. That's enough time for a problem or two. Here we come. Now I'm gonna give you a choice because it doesn't matter to me. Would you rather do a couple problems, or would you rather do a couple ranking tasks? Woo! I have built some ranking task love. Oh.
I am not a fan.
Need more practice.
Go. This should not be hard. Go.
It's really slow to get like the conceptual.
I agree. Go, 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 go. Stop
They're
talking
being
and
pushed.
physics.
You don't have to simplify them very much, because you just have to compare them. You don't have to tell me what the accelerations are. I mean, yes, life is hard.
That's funny. She just gave you a look. That's a good look.
That laugh. I like that.
It was funny. The conversation over here too. Wow. She said, "What's something divided by something that was something she should build?" And she's like, "I am not going to answer that." It was pretty funny.
That's my sister.
No, it's 5. No, it's 12. 5. No. Do you want me to get your calculator? It's fine. Just look it out for you. It was literally. Yeah. I got it at 4. Once you talk to your table mates, Tatum, you might need to find, you can come talk to these ladies over here if you want. Discuss real quick, make sure you have you're in agreement, and then we will compare quick.
I haven't finished yet. Hold on.
Yeah, sure.
So which one is which now?
Alright. What's that? I don't know.
It's from greatest to least.
Okay.
You solved the side calculator?
Arthur fraction, right?
Oh, okay.
Find that
You said
one.
the side.
Alright, so I got A is greater
I like how that was just conceptual.
is greater than C is greater.
It's not just beyond.
I agree with you. Okay, I
What
got
class are you going to next?
650.
I mean, I'm not judging.
Yeah.
Sometimes arithmetic is hard. I
Well,
get
honestly,
that.
so I can't memorize.
I'm just saying.
This is like B is equal to D and C is greater than A.
Derivative
Does
fun
that
time?
even mean?
No.
It means.
You're gonna do
No,
40
that's
divided by
confusing.
mass.
Like,
So 100 divided by 15, 75 divided by 20, 50 divided by 30.
it just says.
Yep.
Oh my goodness, oh my goodness. Do we have an answer?
A is greater than D is greater than C is greater than B.
A is greater than,
D.
okay?
And
C
is the least.
greater than, sorry.
Do you guys agree?
Yeah,
Sure.
Happy weekend!